All right, so today we're going to be talking about algebraic expressions. So one of the things in math that we want to be able to do is take a word phrase and make it into an algebraic expression. Okay, so here's our first one. It says write an algebraic expression for the phrase 7 fewer than a number x. Okay, so we want 7 fewer. Well, how do we write 7 fewer? Well, that's -7. Well, where are we taking that 7 fewer from? Okay, well, we're taking it from some number or our variable x, so we end up with x minus 7. Okay, so it's important that we understand phrases like fewer, more, kind of things like that, the product. All right, so we want to expand on this idea and put it into a modeling system where we model kind of real world scenarios. So what we're going to do is we're going to look at this. You start with $20 and save $6 each week. Now we want to write the algebraic model that models the total amount saved. Okay? So we want to know, first of all, we have all this cash that we're talking about, $20 and $6 each week. How much are you gaining each week? Well, the answer is 6. So the amount that's changing is this, it's weekly. So we need to come up with a variable that represents that. So I'm going to use W. And I'm going to let W stand for weeks. How many weeks are you planning on saving to get that total? Okay? Well, how much are you saving each week? So that's $6. Okay? Well, you started off with something. You started off with $20. So we're going to add that to that total. So this ends up becoming our grand total of 6W plus 20. So if I were to say, well, how much would you have after 2 weeks? Here goes 6 times 2 is 12. 12 plus 20 is 32. So you then can evaluate that. Okay? Which brings us to the word evaluate. When I have the word evaluate, what that word means is that means I have some value for the variable that I'm going to plug in. Okay? So I need to take that value and plug it in. So the first one says evaluate 7 times the quantity A plus 4 quantity plus 3B minus 8. For the values of A equals -4 and B equals 5. So I'm going to take these values and plug them in. So I'm going to go here, I'm going to go 7 times -4 plus 4 plus 3 times 5 minus 8. All right. So here I end up with 0. 7 times 0 plus 5 times 3 is 15 minus 8. 7 times 0 is 0 plus 15 minus 8 equals 7. So what we're looking at, when you see the word evaluate, we're looking at plugging something in and getting a value. We want a single numeric value. So now we're going to come here and we're going to plug in 1 for x and a half for y. So I have 1 over 2 plus 1/2 squared. So 1/2 plus, well, 1/2 squared is 1/2 times 1/2. Or I can square the 1, which gives me 1, square the 2, which is 4. So now I have a half plus a fourth. Well, we're going to combine these. I need to create a common denominator because I'm adding fractions. The common denominator between 2 and 4 is 4. So I'm going to take and multiply this first one by 2 over 2. That gives me 2/4 plus 1/4, which gives me a grand total of 3/4. Okay? So make sure you remember how to add fractions. So the last thing we're going to talk about today is combining like terms. So the first thing is, what is a like term? A like term is a term which has the same variable and the same power attached to that variable. So if I'm looking at a term, that is a single value. So if I'm here, if I have 5x squared, and I'm looking at 3x, okay, so these are two separate terms. But when I look at it, do they have the same variable? Yes. Do they have the same power attached to that variable? No. So these are not like terms then. So to make these like terms, they have to have the same power. Okay, now they're like terms, and I'm going to add the coefficients. So these numbers in front are called the coefficients. I would add those together and get 8x. If I have multiple variables, 5xy and 3x squared y, all the variables have to match up. So here we have the same variables, so that's good. But do the powers match up for each variable? And right now the answer is no, because I have x to the first power and x squared. So these are not like, and I would not be able to combine them. So when we're looking at combining like terms, we're going to add or subtract the coefficients. So what I'm going to do is I'm going to look up here. I have 7x squared plus 3y plus 2y minus 4x squared. So a lot of times I will draw kind of around my like terms there and create which ones are together. So I have here, I'm going to rearrange them. 7x squared minus 4x squared plus 3y squared plus 2y squared. And what I'm going to do is I'm going to combine the coefficients. So this really becomes 7 minus 4x squared plus 3 plus 2 y squared. 7 minus 4 is 3x squared plus 5y squared. So I'm going to take my coefficients and I'm going to add or subtract them accordingly. And that becomes the new coefficient in front of it. Okay? So the next one, we have a little bit more work to do. So we have to do some distribution and then combining like terms. So the first thing I'm going to do is distribute. So I'm going to distribute my negative sign through. So this becomes negative 3k minus m plus 2k minus 8m. So I've distributed. I can now look to see if I have like terms. Well, it looks like I have some like terms here, and it looks like I have like terms there. So I'm going to reorder these. So I have negative 3k plus 2k minus m minus 8m. And I'm going to take my coefficients and I'm going to put them in a parenthesis. Negative 3 plus 2k plus negative 1 minus 8m. Because there is an implied 1 there. Okay? So negative 3 plus 2 gives me negative 1. I'm not going to write it. I'm just going to write the negative. Plus negative 9m. I don't really need plus minus. So I'm going to go negative k minus 9m. Now, do we have to do it like this every single time? No, a lot of you are going to jump right from here down to here. And that's okay. It's all right to kind of already see that and have that in your head. But remember, when you're combining like terms, you have to have the same variable and the same power attached to that variable.